by Soto, Pauletti, and Meneghetti, experiment on flexible surface formworks for thin shells.
Thank you, Amadeo, for the introduction. Are you seeing my screen?
Yes, very well.
Okay. This work has been developed during my master's and consists of a series of experimental models aiming to gather practical and empirical experience with flexible formworks. Just to introduce the subject, I present here some Brazilian examples of concrete shells which structural efficiency allowed very thin thickness and large free spans, which reflecting material savings and reduction in environmental impacts. However, the costs involved with labor and material of temporary support systems can reach up to 6% of the structure cost, being one of the factors that led research to develop alternative formwork systems that explore the viability of textile and membrane molds. Based on how the model is stressed and how the concrete is applied, flexible formworks can be divided in fillet and surface molds. Considering the construction process, there are 4 possible families of surface molds reflecting different geometries according to the technique used. Aiming to study different types of flexible molds, 5 small-scale experiments were carried out using pre-stressed and freely hanging membranes, generating shells with different geometries and construction challenges. In the first experiment, a spherical surface was produced by pneumatically pre-stressing a plastic membrane. The mold and the reinforcement were developed with a pattern technique analytically achieved. The final shell remaining 5 millimeters thickness and presented some local damages originated from application forces and the molding process. Another model was based on Eisler experiments with hanging shells using a cotton textile attached to a wooden frame. The shell was conceived to have a central oculus and did not require pattern techniques. The mold remained loose after the casting process, having developed plastic deformations, and the finished shell surface presented air voids due to lack of concrete compaction. In sequence, 2 anticlassic shells were produced from a mechanically pre-stressed membrane mold. In the first model, a white cement mortar was applied with polypropylene fibers and superplasticizer to prevent shrinkage and to improve workability. The average shell thickness obtained was 2.5 millimeters. For the second application, a cement mortar was shotcrete on the mold, also with polypropylene fibers. The mortar projection was stopped when achieved half of the final thickness at 1.5 millimeters height to place reinforcement and curing of concrete. Both experiments were successful, but the use of shotcrete enabled a new range of applications. And in order to test the limits of shotcrete casting, a very flexible membrane tensigrid sculpture was used as a mold. The casting process was made in 2 steps. Firstly, a thin layer of a polymer composite was applied, aiming to minimize the mold deformability. The second layer was composed by the same cement mortar used at the previous experiment, and the mold deformed considerably during the second application, causing excessive displacement and cracking around the support points. So from the tabletop models presented, we could identify some critical aspects regarding the concrete casting process of a shell structure with flexible formworks. A good specification of the concrete is decisive to the application success. Also, the use of polypropylene fibers to control shrinkage stresses showed as an efficient solution in the scale studied. About the casting process, it was noted that it should begin at support boundaries and continue symmetrically. Also, it is important to notice that the final geometry will be highly impacted by the contribution of the first concrete layer. Concluding, among the techniques applied, pre-stressed formwork showed the best results due to the better control of the mold stiffness. And it is important to notice that the small-scale experiments presented here did not provide the challenge of concreting a structure at a relevant scale, covering its support elements as foundations, columns, beyond rings, and also the centering problems that might occur. Those details will be part of a future research involving firstly a 1/30 scale model of the Memorial dos Povos at Belém do Pará, Brazil. We acknowledge the support of Brazilian agency CAPS and the company Art Spray. Thank you all for listening.
Thank you so much, Murillo. And I think that we have a question from Francesco Marmo. Please, Francesco.
Yes, it's just my curiosity. How do you control the thickness of the mortar?
Yes, this is a problem in the casting process. With the first model, we used some kind of spacers to control the thickness, but with the projection of the Shotcrete process, the thickness was controlled by the operator. So it involves a little of ability and the experience of the operator of the machine. And we control it with the amount of material applied, weighting the material that was applied.
So you have just an average information about the thickness.
Yes.
Not a point plus one.
When casting, yes, but after we could measure.
Thank you.
Thank you.
Well, thank you so much, Murillo, again for the presentation. I don't see.
There is a question by Sigrid, I think.
Okay.
Oh, sorry.
If there is time. I have a question. So some of the techniques are like form finding techniques, right? But in real life, for example, the hanging shell, would you cast it hanging and then invert it? I mean, that would be a lot of work. So actually, that was not my question. My question was more related. You mentioned the word reinforcement, but so I understand in your models, there is no reinforcement, but do you have any thought as in if you were to build this at the full scale? Well, so I think I have two questions. One is like the hanging model, like you cannot really turn that upside down, right? So that's one question. So how do you see these techniques being used at the full scale? And the secondly is what about reinforcement? How important is that when you are like doing these experiments?
Okay, thank you for the question. For the first part, the hanging either use the hanging shell model to predict the final shape, the best shape, funicular shape of the shell. So I used it here I use the model to conform the concrete with the hanging shell and inverted after the casting process. It could be applied for small pieces or for precasted pieces to concrete a larger structure, but in larger models it could not be possible to concrete the entire structure then invert. And the second part was about the reinforcement. We use reinforcement in the pneumatic shell and in the Shotcrete saddle membrane. Was important to improve the material strength. So we use a textile glass textile fiber textile made of glass fibers. And the fibers that I mentioned, the polypropylene fibers, was used just to prevent shrinkage stresses.
Thank you.
Well, thank you so much, Murillo, for the answer, and Professor Adriansel for.
Thank you all.